Hello guys, today we are going to see this problem, minimum size subarray sum. So the problem goes like this, that we are given an array of positive integers and a positive integer target, and we have to return the minimal length of a subarray whose sum is greater than or equal to target. And if there is no subarray, we have to return 0. For example, we have uh, uh, in- uh, the nums given here and we have a target given here. So let's move into here and let's check how many subarrays are there. So for this, from this nums array, how many subarrays we can create? So first, remember that there are two things, subarray and subsequence. Subarray is always contiguous and subsequence can be non-contiguous. So what subarrays we can have? We can have two, we can have 2 3, then we can have 2 3 1. uh, Definitely commas in between, I'm just not putting it to save time. Then we can have 2 3 1 2, we can have 2 3 1 2 4, 2 3 1 2 4 3. So these are all subarrays starting from 2, that is index 0. Then what are all subarrays starting from index 3? So what we can have, we can have 3, we can have 3 1, then we can have 3 2 3. This is 2 3 1 2 3 1 2, sorry, 2 3 1 2. So with this we'll have 3 1 2, and then we'll have 3 1 2 4, 3 1 2 4, and then we'll have 3 1 2 4 3. What are the subarrays which can start from 1 1 1 2? So what I'm taking here is 1 1 2, then 1 2 4, and then 1 2 3 1 2 4 3. Okay, 1 2 4 3. What is subarray starting from index 0 1 2 3, index 3, that is element 2? We can have how many subarrays? 2 2 4 2 3 4. Then from index um, that is this element 4, how many subarrays? 4 and 4 3. And finally the last element can have only one subarray, right? So these are all contiguous. So the question says is we have to return um, length of the subarray whose sum is greater than or equal to target. So for example, if we see here 2 3, its sum is 5, it is smaller than 7. 2 3 1, sum is 6, smaller than 7. 2 3 1 2, its sum becomes 5 7 and 8. Okay, so but its length is what? Its length is 4, right? So let me write its length in bracket. It's 4. So once we have a, a subarray whose sum is greater than 4, we'll not go ahead on these subarrays, right? We can ignore them. So we can not go there. Then let's go to the other subarrays. This is 3 3 1 3 1 2, then 3 1 2 4. This is also greater than 4, whose length is 4. So we'll not again go on these subarrays. Then we have 1 1 2 1 2 4. Okay, this is equal to sum, so its length is 3. So we'll not go on this. And then we'll have 2 2 4 2 3 4. Its length, its sum is greater than 7, that is 9, and its length is 3. Good. So this is 7, right? And this is 3. So our answer will be 3 4, and its length will be 2. So our answer will be 2, and the subarray which we'll be considering is 4 3. So how we are going to do it? So one way is we can have two for loops. So in first for loop we can start from index 0, uh, and in second for loop we can start from index j, which starts from I plus 1, right? So we can do something like this. So we can have our first I here, and then we can have j here, and then we'll move j. So we'll have I j, like sum is 2 3, then sum is 6, then sum is uh, 8. So now in this case we'll not move forward, and we'll move over I. So I comes here and then j comes here, right? So then again we'll move j and find the sum, right? Then jam till here, but the time complexity of this algorithm will be O(n) square, right? Because be using two for loops. So to reduce the time complexity, what we can use is we'll be using a sliding window mechanism here. So and why sliding window? Um, because we found that we are actually traversing every element again and again. Earlier we have traversed 2312, then again we are traversing 312. So in place, how we can do is, okay, let us go through the sliding window approach. Okay, so we'll have element something like this. So we'll have our window start here, and we'll have our window end here as well. So we'll have two pointers, that is start and end, right? So what we'll check that uh, we'll check the sum of the window sum. If it is smaller than the target, then we have to increase the end. So the window is only 2 and the sum is 2, which is smaller than 7. So we'll increment end pointer. So now our window becomes 2, 3 and our sum is 5. It is still smaller than 7. We'll increment it again. Now our window is 2, 3, 1, whose sum is 6, still smaller than 7. Now our window is 2, 3, 1, 2, whose sum is 5, 7, and 8, and it is greater than 7. Now what we'll do, we will reduce the window from the other end. That is, we will increment the start, right? E will be here only. So when we'll increment the start, our window, so yeah, again, one thing to note here is when the window sum becomes greater than target, we'll note the length. So the length here will be 4. Then we'll reduce the window from the start end. So now our window becomes 6. So this is not good. We'll increase the end, that is E, end pointer of the window. Now we'll see that the sum becomes greater than 7. So we'll again note the length. So the length is 4 and earlier length is also 4. So we'll not increment it because we will do the minimum of all the length we encounter. So now we'll increment the start. So now as we can see the sum is 7, right? And length is 3. So we'll do it 3. So we cannot reduce, we'll reduce it one more time. So now our window becomes 4, 6 and the target, the sum of the window is smaller than the target. So we will increment end. Now our window is length is 3. So because length is 3 and target is greater than target, that is sum is 9. So now we'll reduce the window. So now as you can see the sum is 7 and length is 2. So we'll keep 2. And finally we will, when our S and E again meet, then in that case we'll uh, end the algorithm. So the answer is 2. So let's see the code here. Okay, so um, I have taken three variables. One is called the window start, one is window end, and one is window sum. So minimum length is taken as a int max. So this is int max in C++, which is um, defined as int max in limits.c. That is C++ library provides numeric limits int, while C library provides int max. So now using the for each loop, we are traversing in nums vector, that is from begin to end. And so this basically for each loop is um, it takes a iterator, that is we have nums as a container. It iterates from begin to end and each element will be filled in element, right? So it's something like um, as we do it something like for integer I equal to 0, I smaller than size of the array and I plus plus. So in that case, what we used to do, this is from I equal to 0, which is same as I begin. I smaller than size, which is same as I, and element here will be the vi. So vi will be element, right? Something similar, right? And this is a lambda function. The and in lambda function means that it can take all the environment variables. Hence, we are accessing wsum, nums, w, and inside it. So we are inside a lambda function here, and we are processing in doing all the processing here. So what we did is initially we taken the sum, and nums.at is same as this bracket vi. So wherever the end pointer is, we have taken in the sum, and then we have incremented the end pointer. If sum is becomes greater than the target, then we are taking the minimum length of end minus start and the minimum length which we have already stored. And in that case, we are reducing the window from the start side, right? We are incrementing the start. That means we are reducing the window, even we are reducing the sum, right? And finally, whatever the minimum length we get, we will return the answer as minimum of max if it is max. So that means we didn't find any element in this vector which is smaller than the sum of any elements which is smaller than the target. Hence, we will be returning 0. And this is this case that we'll traverse the window and we'll traverse the whole of the elements, and the total sum is smaller than 11. So we'll return 0. Otherwise, if min length is not equal to the int max or std limits max, we'll return the min length. So this works. The time complexity of this algorithm would be OMN. So MN in the case that n is the length of the nums and m is the maximum window which it can stretch. So for example, in this case, the time complexity will be ON square. But in this case, the time complexity would be the length of the window multiplied by 4. So this is the max window which we can stretch. Yeah. Thanks a lot, guys. Have a good